what was going to happen, what we were going to be able to do, what we were not going to be able to do. The institute students have been affected in many ways, quite seriously. The research scholars had to go after they went home. The research came to a grinding halt. Research scholars are used to sort of plugging away at their research the whole day, 7 days a week. Suddenly, they were completely cut off from their labs. Initially, also cut off from the library because our library access is for security reasons only from the campus usually, and their guides, and also there's a lot of learning and a lot of progress is made by collaboration and conversations with colleagues, other students in the same group, and so on. Everything came to a grinding halt. Of course, our classes also came to a halt. We have managed to recover, as many other institutes have in the country. We have been conducting classes online. Not a very happy situation, but at least not completely hopeless. And students have managed with great difficulty, various parts of the country, difficult learning environments, have managed to make progress and continue with their academic programs. The research scholars also did whatever they could valiantly from their homes for a few months, but then we started getting them back towards the second half of last year into the hostels in a very careful way. And some of the students are staying off campus to reduce the load in the hostels and reduce the risk of an infection breakout. And some are staying on campus. And between the two, I would say we have managed to get back a large part of our research scholar population back who need to work in the labs. There are some of these less, the students who are fairly of recent vintage, 2018, 19, and so on, who are yet to come back. They are also coming back now. And then we'll have to worry about the ones who came on board last year, who joined the institute and have not seen the institute at all. So we have to see how to bring them back also. So the next few months, because the second wave is on now, we have to see how to go about it. And we hope that there won't be another outbreak in our hostels. We had one last December. But my students have been managing, have been doing their research. People have been graduating, submitting their thesis. So it's remarkable. I mean, first thing I want to say is that it's a great learning experience for all of us, but particularly for these students, these scholars. After facing this and overcoming the challenges, I think they'll be ready to face a lot of challenges in their academic and professional and personal lives, professional careers and personal lives. So I would say this has been a great learning experience, though it is very difficult. The students, our research scholars conduct a fantastic program every year, lasting 2-3 days. A research scholars day, they called it initially, but it became more like a research scholars week, where they showcase the work of the senior scholars, where they have a lot of workshops and sessions for scholars conducted with experts from outside, motivating talks by world-leading researchers and so on. And this year, all of that has gone online. And I must say that having browsed through the program that they've put together, it's amazing what they're able to do despite the difficult conditions and despite not being able to have a face-to-face research scholars day program. So I must congratulate them. And I think, of course, our cultural festival, our technical festival, everything was online this year. So this is following the same tradition. I'm sure this program will also be a success. And though it cannot match a live program on campus, it won't be a very far second. It will be a reasonably close second choice to what we normally do. And I want to congratulate Rohit and his team for putting this program together. I've glanced through the program. It looks very interesting. I hope the research scholars who are on campus, but some are, as I said, still in their homes, especially the junior ones, so to speak. And I hope they're all able to feel connected and get some benefit from this online program. And hopefully by next year, we'll be back to our usual routine. So I want to end here by wishing Research Scholars Day this year, 2021, all success and more strength to our scholars who are, as I said, doing a valiant job. Thank you.
Thank you very much for your encouraging words, sir. I would now like to ask you to declare the release of the RST booklet, which we release every year, honoring our alumni. Once you have declared it open, I will share an image of the booklet and we will then disseminate it among our scholars as well.
I'm very happy, Rohit, to declare that the Research Scholars booklet for 2020-21 is released today. And it contains very useful information about the scholars who have graduated. And I look forward to receiving a copy of this.
Thank you very much, sir, for that. Thank you all for your encouraging words as well. We will now move forward with the presentation of the report, annual report by the Research Affairs Secretary. And this will give you an highlight about what are the activities happening on the campus as a part of the research scholars, what is the students team of research scholars working for, and I hope it is informative to everyone present here. So when we started this thing, as an overview, I would want to say that there are over 3,000 MS and PhD scholars on the campus spread across 16 departments. And what our activities are focused towards is to encourage, empower, and enhance the research scholars' journey throughout the careers and throughout their campus experiences. What we provide avenue is for growth, networking, collaborations, career advancements, and awareness. So there are certain things that all the teams are working towards the benefit of the scholars. Given the fact that COVID-19 had impacted our activities on the campus, we took everything online and all the events and sessions were attended on Meet, Zoom, WebEx, and MS Teams. Social media was a big player this year because all of our activities were shared with the students via social media platforms like Facebook, Instagram, and WhatsApp. And we kept connected with the scholars during these times. All these sessions, mostly which are not recorded in when it is live on the campus, is currently being recorded and shared with all the scholars who have some network connectivity issues or are not available at that time for their use at a later date. Also, it is very encouraging to see that the scholars community on the campus has been very appreciative of the initiatives taken by us, and they have participated in large numbers in everything we are doing. So to give you an overview of the activities in a Research Scholars Day, uh, we would say that this Research Scholars Day is the 9th edition. We have over 40 events, including workshops, lectures, and competitions. We also have a research expo, which is showcasing the advancements in research happening across the campus as well as outside the campus. Overall, we have received participation from more than 200 scholars across the India. Many of them are our scholars, and many of them from other IITs, NITs, and various other institutions. The entire team which worked behind RST 2021 comprises of 35 scholars, and we have several volunteers, and we have worked over 3 months to actually execute this properly. Going ahead with the activities, the placement activities on the campus were conducted entirely online. And to prepare the scholars for that, we had a series of sessions conducted to improve their readiness and employability skills. So we had an alumni series where a lot of alumni who had been recently graduated shared their experience with the placements. We created a resume archive for the previous scholars who had cracked the interviews. Because this was the first online edition where interviews will be taken virtually, we had an awareness session of how to handle online interviews as well as the etiquettes. We also, for people who were interested in academic positions, we had a recruitment process and detailing out the list of things that they might be looked at in the premier institutions. We also had a session for postdoctoral opportunities where we shared the process of postdoctoral things and the way forward for that. All of this thing was recorded. We supported the entire students sitting for placements with infrastructure and support for helping them get an equal opportunity during the placements. And this entire placements activity was handled by more than 75 scholars who were working towards the placement for the scholars team. Going ahead, placement is one side, but the skill building which is required to get employability better is another side of it. And my entire team was working towards that. The skill building activities taken care by career development cell research had series of workshops, events, awareness sessions, and lectures for the benefit of the scholars. That included several of the things mentioned here, including some of the softwares which were used regularly by all the scholars on the campus. Every session was attended by more than 100 plus scholars, which showed the enthusiasm of the scholars to be available and to learn from every session that we conducted. Other activities, other than these already mentioned, included the orientation session. We had the first virtual orientation for the scholars. We had more than 3-4 sessions for entrepreneurship, where we showed the scholars how research can be converted to an entrepreneurial business. We had a session on biomimicry to learn from the nature. We had a series of topics on social media, specifically Instagram, where we connected with a different set of people who were pursuing a PhD and research in various different fields and had an informal talk with them under the banner of Infinity. We also conducted a 5-minute thesis presentation for the scholars who were there in the final stages. And we gave them the opportunity to present in front of experts from industries like Mercedes and Fords so that they could share their valuable impact, valuable feedback. And then the scholars can have the research better. All of this thing was supported by a platform which we have developed, which is the Scholars Portal. It is the latest initiative where almost 1,000 plus scholars have been registered. And there is a lot of facilities on this portal, which is very beneficial to every scholar, such as every announcement that we are making, every important detail or document which might get lost somewhere is kept here as a compendium. The scholars can connect with each other. They can see what research they are doing. They can connect with companies, alumni, and various other places. Also, recently we have introduced the internship opportunities where any internship opportunity will be shared with every scholar who is interested in it. The automatic resume generation is a big help to them as their resumes tend to be a little longer, and this helps them generate it automatically. So this scholars portal has become a one-stop shop for any use or any important information that the scholar might require. Going forward, we plan to continue the same set of work and enhance it as well. We have already taken feedback from every scholar on the campus, and we will try to incorporate it in the coming days. We want to improve the online presence of Research Sphere. We want to improve the content availability, as well as we want to improve the workshops in the specific departments and other methodologies. So with that, this is the research report for the year 2021. And I will take any questions if you have right now. Okay, thank you very much for that. I would now like to ask Dean Research, Sir, Dr. Ashok Mishra, to give his presentation and address the audience. Sir, up to you, sir.
Thank you, Rohit. Can you hear me?
Yes, sir, you're audible, sir. Yeah.
So I don't have any presentation. I'm just going to speak a little bit for the next 4 or 5 minutes. So in fact, I echo what our director, Professor Bhaskaramurthy said, that I'm indeed happy that our research scholars throughout the year have been able to continue their year-long activity. Although we started Research Scholar Day as a day, it has almost become year-long now, culminating in these few days of very intense activity. So it has been going on, and as you showed, it has been really successful. I'm really happy that the intensity has not dropped down as I have seen in previous years. In fact, it is much better than what it was last year, I would say. So I'm happy that again for this next couple of days, you have been able to get some really distinguished speakers who are leaders in their areas, in their fields. And I'm sure the scholars who will be participating, I will be seeing them, hearing them later also, recorded projects. They'll be benefited. The only thing that probably will be missing is all those question answer session can go on in this forum. I don't know how much effective it will be. But I remember that after the end of the session, the scholars used to crowd around the speaker and directly interact with them, talking to them. That kind of thrill that comes in-person interaction, that is going to miss. Anyway, so what I have been seeing for the last 5 years or 6 years is that this RSD related activities has been really increasing gradually, but steadily. It is increasing. The level of interaction among scholars has increased, as I have seen through various those kind of meetings and forums and so on. And this, I hope, keeps getting stronger and stronger by the day. You know, the more the scholars of different expertise areas interact, you know, the ideas that can generate will be probably much more fertile and much more original in that sense. Much more, yes. So I'm sure this is a scholar day related. We must have a good name for it. I think we have been calling it a day. Get a good name so that it will take care of the whole year. This line of activities that you have. So it should thrive and go on. I have just one request. See this the scholars portal that we have built up for the last 4 or 5 years, and in fact this year it has been much better. Thanks to Rohit and his team, it has value added a lot. The portal is very good now. What is important is that, see, you talked about 1,000 scholars who have registered, but he also said that you know, quite a few of them are old, right? 2017 onwards, they are just okay. So typically, I would expect around 1,000 scholars every year. You see, roughly we have close to 4,000 scholars, not 3,000. Roughly 3,000 research scholars and another 700, 800 of MS scholars. I mean, PhDs are around close to 3,000. So out of that, the graduating scholars will be of the order of 800 to. Okay. So I would expect that all of them should register, and not only register, they should keep on updating the resume. Because it will be coming in very handy. For example, you already know that, I mean, some of you know, that recently there was a request from the director of IIT ISM Madras asking for some fresh graduates, PhD graduates in certain areas, some areas that he mentioned, and he wanted those people to apply. So we have circulated that people will be applying, or scholars will be applying. They want fresh PhDs. It's interesting. On top of it, we are going to share this scholar portal now with the director, that they can pick that. Maybe even if somebody has not applied, somebody has missed out, and they find that that's an area they want, they can probably find out. It's a very nice searchable portal. Right? So I would urge all the research scholars, at least those scholars who are in the final year of graduation, to not only register there and get the resume ready and keep on updating the resume as and when they get a new publications or any award or anything that they can. So very nice. And what we can do also is that this portal links, we thought of circulating to all this industry which are associated with IIT Madras, right? And make sure they talk to the ICSR and and so on. We can circulate that.
Sure.
This version of the portal, so that's the only thing that I had to say. And now that this meeting will start with Dr. Kallol, keynote speaker. I welcome Dr. Ray. Sir, if you are there, Dr. Ray is there.
Yes, sir. I'm just, thank you so much, sir. Thank you so much.
So, our heartfelt thanks for accepting this. And I understand that you are here with us in IIT Madras now.
I have formally retired from this as a CMD, and I feel myself a privilege to rejoin here more like a student than anything else, because I feel we should just continue working like a student perpetually.
So it would have been really great. I mean, you are already in campus, let us say, and our scholars are only meeting you through online.
Yes.
Hopefully some opportunity comes to our scholars can directly meet you. I'm indeed happy that you have accepted to be the keynote speaker today.
Thank you, sir.
Thank you, sir. Thank you very much. So Rohit?
Yes, sir. Thank you very much for your kind words and suggestions, sir. So we will now move on to the keynote lecture by Dr. Karol, sir. Before he starts, I wanted to give a small introduction about him. Dr. Karol, sir, is a BTech from NIT Calicut, and he is an MTech from ISC Bangalore, and he is a PhD from IIT Bombay, and has also been a postdoc fellow at the University of Alberta. Prior to joining Bhavini as a CMD, he was an outstanding scientist at BARC and was heading the Research Reactor Maintenance Division. He was also a faculty at HBNI and a member of various committees for AERP. During the past 5 years, he has been involved in the total project management, carrying out in situ modifications and commissioning of various systems and equipments of PFBR. So, sir, over to you. Thank you for joining us and looking forward to your keynote speech, sir.
Thank you so much, Rohit, for the kind introduction. I think kindly let me know if sharing of the screen has been effected. If it has been, then maybe I can actually continue. At the outset, let me thank the Research Scholars team and
Sir, you're on mute, sir.
Yes, go ahead.
I'm sorry, I realized that I was unmuted. Can you come back to the first slide? Yeah, I'm sorry, because the systems are different. And at the outset, let me again, since I was unmuted, let me consider myself greatly privileged to having been invited to this August gathering. I thank Director IIT and the Dean and all the research scholars for having invited me. I would also like to state that some of the slides have been presented earlier by me in some technical meetings on this virtual platform in the last few months in certain societies like Institute of Metals as well as Society for Reliability, etc. So some of them may be a repeat for some who are watching, but then since the target audience primarily is different, maybe I can go ahead with this. I also would like to acknowledge that some of the internet images available in public domain have been used. And so some of these images have been modified suitably. These are only and purely for academic purposes. And hence, I think I can go ahead with these images. The topic for today is essentially trying to address specific research areas pertaining to intrinsic safety as well as improved availability in all operation and maintenance of critical infrastructures, keeping in mind a control theoretic and an Industry 4.0 framework. This Industry 4.0 becomes all the more relevant because if I take the clue from what Director just now had to say about the disadvantages of the pandemic, but I think everything has a silver lining. The concept of this pandemic has brought the entire community all over India, even from remote areas, together through these virtual platforms. Many who couldn't possibly had the privilege of attending such gatherings are now able to attend because of much better connectivity all over. So I suppose there are advantages of anything or any upheavals which take place in the world. Along with all its disadvantages, they do throw up some advantages. So I would think the Industry 4.0 framework is indeed going to help in bringing about more amount of research towards improved bandwidth, much better connectivity, maybe smartphones becoming much, much cheaper, maybe availability and accessibility of all sorts of privileged information to many more underprivileged people who otherwise couldn't get it. So from all those point of view, I think this Industry 4.0 framework has indeed been useful and properly utilized to the hilt because of this pandemic. The control theoretic part in intrinsic safety is something, again, which the pandemic has a bearing, because let us understand, because of the pandemic situation, many critical infrastructures had to shut down and finally had to restart with less manpower, which always had issues in terms of safety. Now, can we not think of making our research in such a manner that all control actuators, sensors, and everything can make these systems intrinsically safe? A typical example I would take is a weight valve of a pressure cooker. How many housewives all over the country or all over the world would really switch on the cooker and keep monitoring the pressure through a pressure gauge and monitor temperature through a thermocouple and really find out how safe is the cooking process? It isn't, because we consider it intrinsically safe. We know if the pressure goes up, the relief valve is going to actuate, release the pressure, and then there are backup devices, like even the gasket can go through. There's a fusible plug which releases. So you see, it's a simple process, but intrinsically safe. Now, can we not go ahead and make all our industries intrinsically safe, which would give much greater confidence to our people at large to really accept them and maybe accept such critical industries very close to the townships itself without feeling anything or without even batting an eyelid? Now, you see, the Industry 4.0, as has been understood, are, big data, are essentially big data, system integration, Internet of Things, simulation, additive manufacturing, so on and so forth. All these things are part of the development, and the nomenclature of 4.0 was made in Germany way back in 2012. But from now, we keep talking that what all these things throw up. Maybe it has its pitfalls in terms of too much of AI, bringing in a reduction of employability, but at the same time throwing up a huge amount of avenues for more development of AI-based systems, thereby increasing the employability. You see, the concept is, in any large industry, moment we talk of an intrinsic safety, then we can think of everything around it. We can think of forecasting. The managers can act on the system. We can bring about smart systems, which are possible due to Industry 4.0. Keeping in mind, of course, the traditional feedback controls to observe changes and bring in changes. We use predictor corrective methods and also optimize to ensure that the profits do take place, because profits availability are the prime governing factors, at the same time not sort of compromising at all on the intrinsic safety issues or the basic safety issues. So broadly, the industry managers over the past maybe 10 years nearly have been working more towards data, which is now giving way to big data and, of course, system integration. Then Internet of Things, these IoT devices are helping quite a lot in sensors which are plugged into the system to communicate to the outside world without really having cables in them. In fact, domestically, maybe even our energy meters at home have got IoT devices plugged into it. A large growth in simulators and augmented reality for training of personnel, especially in inaccessible areas in the plant, where a person cannot enter when the plant is operating, but then can have an augmented reality or virtual reality to do it. So you see, all these things have thrown a plethora of understanding, which helps both in availability as well as safety build-up. Now, let us see what are the areas in which we can actually pursue research more in terms of micro and small scale research, which are really the strengths of the country for the future. Just as a matter of understanding, I was once reading up about one femtoampere meter, Keithley, which was very popular even 20 years back for measuring picoamperes. They are now going up to attoamperes, that's 10 to the power of minus 18. So Joseph Keithley, it is said, started his entire industry in his parents' attic. And the only asset he had was an MIT master's from MIT, Massachusetts Institute of Technology. And today, Keithley is a world leader. So it's used in biological devices, medical devices, and of course, in nuclear instrumentation, wherever you're trying to measure currents of the order of 10 to the power of minus 15 to minus 80. So you see, ultimately, it's a small scale, micro, medium, small scale, what have you, which has proved to be the strength in terms of conglomerating all of them and making them suitable for big industries. So the point is, in case we do have a large amount of research potential, the source of it would be in startups, the source of it would be in medium and small scale. Because if I talk of large plants, they still talk in terms of, a essential control loop, which we talked of. But the prognostics and diagnostics would get into, and the smart systems all can be developed offline. And along with all that, we need a large amount of technology forecasting, which is possible only if we are really trying to find out how things are going to change. And the second point is, of course, optimizing the various operating parameters, because unless you minimize the cost function, unless you actually improve the availability factor and you're able to improve profits, no company owner will be really willing to start. So, all the buzzwords of today's management, the lean and the Six Sigma issues are being applied to plants also, where you can define, measure, analyze, improve, and control all your production in the plant, generation in the plant. So be it nuclear, aerospace, transportation, maritime industry, you need to work towards meeting newer safety requirements, because as days go by, both from environment point of view, both from public point of view, the asking rate for safety would be very high. You need to optimize the cost, and you of course need to improve your availability and capacity factors, else you can't make profits to sustain. Well, so this specific area where a researcher would be concerned, I would feel over my many years of experience that particularly in nuclear industry, and based on my understanding with my friends from aerospace as well as transportation elsewhere, they depend more heavily on MSMEs because they need custom-built products. Now, the problem with large industries are they would make products in hundreds and thousands of a very standard specification. Whereas if you wish to get a few of them, which are customized, which undergo rigorous testing, and which need to qualify for all the standards and codal requirements as desired for a very precision industry, highly technical industry, and where safety is of utmost criticality, then maybe the particular concern has to be on making these customized products. The person who develops this industry also needs to understand research. He also needs to work towards cutting edge, and he needs to combine his core strength with many other people. So you need to work towards a combined core strength where fabrication strategies, system domain knowledges, even maths and basic sciences need to be understood and analyzed. Various analytical tools has to be understood, and all the niche areas has to be worked. So a multidisciplinary approach, which takes care of the total basket of all sustainable parts, robust designs, adaptive models, all these things are worked together. Only then we can make products which are precision, cutting edge. And as they said, post-World War II, one of the biggest strengths of the US development of industry has been due to their small scale, medium scale, specialized industries, which fed to the large systems. And it is this which brought in cutting edge and precision industrial growth. So you see, ultimately, in this area of Industry 4.0, let us look at the advantage. It has helped us to do a lot of virtual learning. So while the academic and basic research institutions and the scientific and industrial policies of the government continues, the R&D labs, which were earlier very large R&D labs, they can now be broken up into small R&Ds, small startups which make and work on specialization. And not all people who work in these labs need to really go through a formal, very large scale academics setup or degrees. There could be few of them from these large scale academic research, few of them with very high level of skill sets. They can actually train a whole lot of customized skill development programs. They can work on specialized customized training modules and feed into the large manufacturing and production infrastructure, power industries, etc. So this is a very big growth potential if educated, top-notch PhDs from leading industries are actually into major startups which search for niche areas in various manufacturing, infra, and other places, and really look for making such development. In the recent past, on many, many such areas, we have been actually reaching out to MSMEs who are willing to listen to us, who are willing to customize the product and finally deliver the product. And that would make the key difference, because in our type of industry, we are not always looking for hundreds and hundreds of products. We may look for maybe few, but we will ask for hundreds of tests. So naturally, these are the places where this small scale and startups of precision type make a difference. So you see, the technology forecast growth is also a very important thing for these startups. They should also continuously look into various academic works and do a lot of patent informatics, that is, look into patents and try to find out how the informatics of the patent growths are taking place. Well, and make a together plan for a technology forecast and do a good amount of math, because even today, if you have to do a technology management, you need a whole lot of math models getting in. You need multivariate time series, Bayesian forecasting, good supply chain assessment, because once you talk of industrial growth, the supply chain becomes very important. Many times in an Indian setup, we find difficulties in not having the right supply chain in place. You can't blame the supply chain also, because a small manufacturer would like a steady supply to a standard industry so that he makes his regular bread and butter. He can do his research beyond, over and above that. So I suppose it's a combination of both, and combination of growth in technology, forecasting technology, and growth in that direction, where we should actually work towards. And precisely such type of R&D forums, such type of researchers who are doing these works can play a very major role, and it can actually be a game changer for the country's industry as we go ahead. Okay. Broadly looking into the safety and availability in today's world, let us understand that this industry 4.0, when I talk of, essentially talks of a large amount of cyber physical systems. So there was a time when computerization and automation was going on, but then a cyber physical system requires a different level of skill set. Let us say in earlier days, a person used push buttons with galvanometers and readings to operate a moving machinery. Today, he does that with a menu-driven remote control. So the skill sets for operating that and the safety issue in that is again different, because the moment you have handheld instruments, when I have a handheld equipment, which is a menu-driven one, it means it has got a software. It means that software has to be qualified. It means I have to go through a large verification validation procedure. So to make that intrinsically safe, along with all the benefits it offers, is going to be a different work. It's going to require different levels of research and going to require different levels of specific focused study. So when it comes to smart controls, when I have programmable FPGAs and other devices plugged into controls, and when the programs get properly validated, only then these cyber physical systems would actually be qualified to be stated as intrinsically safe. Now, this would be a requirement because the benefits which it gives has to actually translate in critical industry. You see, most critical industries, we categorize safety as a basic safety envelope, which helps in tripping the plant. There can be no compromise in that. There has to be all designs for safety. And these things are 100% proven, and reliability should be very high. Failure probability is less than 10 to the power of -6. Maybe we should push it to 1 order higher. Now there are safety related envelopes where it remains in that domain. And if this domain gets violated, the safety envelope comes in. Then we have plant-wide monitoring envelope, and then we have failure postulations, hazard analysis, all these things which come in that. So now, can I replace this safety envelope with an intrinsically safe system? At the outset, let's look into what goes into design this. To start with, we need redundant systems. You may have temporal or physical redundancies, because temporal redundancies are that which is connected to the model of the plant. You need to have diversities, and of course, single failure criteria. Mind you, nuclear has derived most of its standards from marine and air. The single failure criteria, classic example which brought in was in the 50s, a DC-3 aircraft had a crash because there's a single lead screw which was being controlled, and a rudder was being controlled by a single lead screw. Now the lead screw had got jammed. So despite what the pilot would do with his automation, he wouldn't achieve it because the lead screw had got jammed. So then the aerospace decided that fine, you cannot have one single equipment which decides the fate or the safety of an equipment or a system. So you must have two systems which are diverse. Diversity also has to be understood in a very simple way. Maybe way back, people who read Arthur Haley, there was a novel called Flight into Danger. It was also rewritten as Runway 08, where everyone falls ill eating a particular preparation of food. So from that, the airlines industry today says the pilot and co-pilot's food should come from different cafeterias. So that's sort of a diversity we talk of. Well, in nuclear industry, we talk of diversity when the fail-safe principles are used as intrinsic safety and two different principles are used for shutting down the plants. The same thing is used even in various other industry when it comes to the primary safety devices. Now, the idea of these sensors which come into picture, the whole idea today is, can I plug in these sensors with the same response characteristics along with the actuators, and we can make the systems as small, as robust as possible, not taking recourse to very high order equations, but taking recourse to models which are very simple, which has got simple second order behavior. And then the primary system gets guaranteed more easily. To do that, essentially, we talk of a domain where I integrate the controller and the sensor all in one. So the controller and the sensor, if it can be plugged into the plant, I think my reference would still be the weight valve of a pressure cooker, which is similar to a standard relief valve in industry, where the moment the pressure changes, the valve pops out by virtue of its weight and releases the high pressure. Similarly, I can talk of Curie point magnets, where high temperature would cause something to actuate. I can talk of fusible links. So these things should be the primary governing systems towards which we need to design and work. There could be many, many more areas where such intrinsic systems could be talked of. The only things which you have today in industry are as written on top: weight valves, relief valves, oil relief pots, etc. This is an area where both an industrial person who is a safety person and an industrial researcher, a PhD student, all can work together and find out what are the various areas in which such intrinsic safety can actually be built in, and what it means, what it costs. Because the idea is this is not just a research in one domain, but would require research in metallurgy domain, in materials, how to make in plug-in systems, how to take a piezoelectric device, say, and put it inside the concrete so that if the overall loading changes, it could also have a built-in IoT system which communicates to the outside world, and it can actually do both sensing, actuation, feedback, what have you. You could have a vibration sensor which could be plugged in metallurgically, and the vibration sensor could act as a damper if the vibration goes up. It could act as a simple sensor as long as the vibrations are within the given domains. So you see that things have to be encapsulated, which would mean metallurgy hardware. You should keep them in a measurement zone. You should have IoTs, and you should have so on and so forth, a core group which can do a research on a multidisciplinary problem to come out with such systems. So you see, the research problems are galore. It's only a question of how do you reach out and how do you get to it, and how do I combine industry and others together. Conventionally, if you have most of the structures, occasionally they used to be vibrated with the help of a pseudo-random binary sequence generator, and their model studied and their model deviations looked. Now the methods are very simple, where I can embed the sensors either in process systems or in pipings or in rotodynamic equipment. And these embedded sensors could actually pick up the natural vibration of the systems, reconstruct them through a data analytics procedure or a Bayesian estimation procedure, remove the noise from the whole system, and then you actually try to find out at any given time whether the systems are degrading or not. So now I have gone with this advanced smart sensor technology, smart actuator technology. I have moved from the conventional periodic monitoring to online real-time monitoring all system structures as well as equipment. And I can always use the actuators for system identification as and when the need be. But then the whole objective is I have a continuous real-time monitoring of all systems, including static equipments. So you see, the original design now of the safety system design is now getting modified. I have controls or smart controls acting as a bottom line. The single failure criteria I can replace with multiple failure criteria. The confidence of the public goes up, and slowly the safety systems would get replaced with intrinsic safety. So the concept of fault tolerant design, etc., we don't need to really spend additional amount on that. So if the safety systems get into smart sensing, then perhaps intrinsic safety gets in. Fault tolerant design can be replaced with intrinsic safe design. Multiple failure criteria could get into single failure, and various diagnostics and predictive maintenance tools can come in, which makes the system safe. So effectively, you see, the safety envelope, which is the core of all critical infrastructure, has now been replaced by an intrinsic safety envelope. And the smart controls, which would be in both sensors and actuators, along with IoT devices, have actually helped us build that. Again, as I said earlier, in order to build all this, what we say, we need research both in sensors and actuators. There are enough number of researches going on in sensors and actuators, but joining them together and making the correct requirements based on an industrial perspective is perhaps what is a bit lacking. And many more such seminars where industry people participate would perhaps help. Now, within industry, one of the areas of research has always been in proper preventive maintenance to prevent failures. But now there's a paradigm shift, because more you maintain, you shut down the plants for that much time and availabilities are not there. So we have gone in more for predictive maintenance and condition-based maintenance techniques. And this has been a paradigm shift, because the moment we do that, we talk in terms of only touch an equipment or an instrument when there are faults. So for this, this redundancy works. And the most important part which works is if I have math models of systems or simulators which are taking in real-time data and giving out the expected value, the operator merely compares with the expected value and the actual value and checks the difference between the two and decides whether you at all need to do maintenance or not. This would actually bring in a major shift in the maintenance strategies. It reduces manpower. It reduces the total load given to the availability factors of the plant, and also cuts down on various human-oriented, human-induced failures in the plant. So these are some of the things which are actually being put to use, and many more work is still going on. But then, mind you, this calls for a lot of analytical people in an industry. Now, these analytical people can actually look quite a lot into Bayesian methods, which are pretty popular in academic circles. Bayesian methods are pretty popular in aerospace because it uses to monitor the posteriors. It's more used for essentially trying to establish virtual instrumentation concepts in astronomical sciences, aerospace sciences, and quite a lot in chemical engineers these days. But then, as we see, it involves a whole lot of math models. It involves study of dynamics, modeling observations, modeling the probability density functions, the priors, the posteriors, a lot of inferential statistics, and you need to do a lot of estimation techniques, and followed by sequential statistics. So this sort of think tanks based on real life data has to be integrated now with industry if you have to bring in more and more paradigms which bring in shifts in the maintenance strategies in the plant. Oh, these are well-established Kalman filtering techniques, very popular with control theory people. Although Kalman filter is in use from 1965 when Kalman had really formulated it, it is still a research area for applications. And although it has pervaded from the aerospace domain to process industry domain, it still a lot needs to be done to really make many critical infrastructure industry into a more robust, with more think tanks working, more data analytics people working, along with field engineers, and to make it really happen. When it comes to nonlinearities, there are further growths in the research areas, which is the area of Monte Carlo filtering, which is actually a breakthrough. But again, as we said, these things become computationally more difficult, but then the computational part is handled because today we have got very powerful computer tools. But then it also requires a lot of think tanks who can work on models. Now, the beauty of these type of model-based systems, especially data-oriented models, we don't need to go into the rigors of the physics. We can get the data, make the models, work on it, and give a broad idea to the operators to really apply their decision statistics and take call on whether the system is going out of hand, whether there's a predictive behavior whereby the system is tending to go towards unsafe states and to arrest it prior to that, or whether we can actually operate the systems closer to the margins without running the risk of having any failures. So this would help effectively in improving the availability factor in most industrial systems. One of the areas which are becoming pretty much popular is having a dynamic simulation and smart controls together, giving rise to what is called a digital twin, whereby I have a simulated data and a real data, both joining together and then coming out with a concept whereby all my physical assets which are present in the plant, these can be combined to make digital assets. And all these digital assets can be combined along with physical assets to effectively work or help me work on a surrogate system, which is my digital assets. If I work on the digital asset, I can get the understanding what the physical asset is. So the effective time I spend in actual repair of the physical asset would be much less because I have understood the physical assets internals based on digital asset. To make it a little clearer, perhaps we work on what is called a digital twin. Consider a simple machine. If I have a very good FEM model or any other simulation code or a dynamic model, and also make a good 3D modeling, SolidWorks type of software or any such type of 3D modeling, 3D graphics software, and also virtual reality, I can effectively create a digital twin and work on the digital twin when the equipments are running. So this can happen both by modeling or by data. So conventionally, the mined data from physical assets with all its data mining tools can be used to build up these virtual assets which come into picture. And I can actually create from a physical version to a digital version, whereby the first stage could be just by analog indicators. Then the second stage, we could get into digital versions. Then we have hardware in loop simulation. And finally, we have a digital version continuously available. So it's something like this is popular in aerospace engines, where the physical asset is replicated with the digital asset. And effectively, I can keep tweaking my digital asset and finding out what exactly is happening to the physical asset or how to take care of the physical asset with the least amount of downtime. So if you see in a shop floor, a digital twin would look something like this. I have a machine, I have a virtual reality based digital asset, and this digital asset gets continuously updated with real-time data. In the process, I find the total performance of this and take a decision what sort of maintenance I should actually undertake in the physical asset by looking at these digital assets. This has been very nicely used by airline industry. Of course, the intent of it, if it has to go not from equipment level to a system level, then I need big data, where the volume, velocity, and the variety of data increases. But you visualize a situation. If an aircraft takes off from airport A and is destined for airport C, in between it makes a halt at airport B. At airport B, we can actually be monitoring in-flight data and take a decision what sort of preventive maintenance has to be acted upon as the plane lands in airport B. So in the process, I can reduce the downtime of the halt to do all my preventive maintenance and thereby improve my turnaround time. So I do agree, or the scientific community does agree, that it requires large amount of data complexities, but all that in today's computational power being available, these things may not really matter. So this is exactly what we're trying to say. You can have a control room, which is in station B, and as the plane leaves A and is heading for B, and maybe finally going to C, in station B, a continuous performance analysis can be done based on the digital twin available to them. With the help of this, they can make ready all their equipments, all their softwares, all their troubleshooting guides and personnel, and attend to this aircraft, and with a much shorter downtime than we could ever imagine in the past. So this concept of digital twin is really building up. But in large plants, it may become that much more difficult, because if you see a large plant like a nuclear plant may have a large number of loops. You have a huge amount of interconnected process loops. Conventionally, you needed a whole amount of equation solvers, and people would have to understand it separately and offline. Today, I can plug in these equation solvers, which are running in the simulator along with real-time data, update it continuously, and try to understand how these process loops are behaving when the plant is operating. And in the process, I can always plan my preventive maintenance schedules, activities, and decide on the workflow as it takes place whenever the next shutdown comes in. So I can make them even better by having a continuous real-time data coming into the simulator through the wireless sensor networks, and all these real-time data causes the simulator to get updated, and then I can work on it. Only problem is, if I talk of the entire plant, I may have to do much more than simple data analytics. because there are many, many things in the plant, especially when it comes to safety systems and computer-based systems, which are nowadays event-driven. When I say event-driven system, it's an entire plethora of maths called the discrete event system maths, with which we have developed automatons, Petri nets, and so on and so forth, which are standard domains of computer science team. But now this is where the computer science and control engineers and industry engineers have to get together, understand how the cyber-physical domain analytics have to be done in event-driven systems. And if tomorrow I really do wish to talk of a digital twin of a very large plant, on one hand, I need to not only do big data analytics, but I also have to do analytics of data which are not properly classified or clustered, analytics of data which are only available through event logs and field notings. And I have to apply a lot of association rule binding together with cyber-physical methods on event-driven systems. So it's a very tall order, but not impossible, but definitely a tall order which requires a large group of people with a lot of core strengths. And this is exactly where a whole lot of PhD students with plenty of superlative caliber in analysis and technology can join in with the industry majors, work on various domains, and really see how both the research and the industrial availability together with safety really can get gelled in, and we can make a very big game changer with all this. So if you see, if I may sum up the whole thing, any process plant, be it a nuclear plant, be it an aero industry, be it transportation, with smart controls, I can bring in intrinsic safety. And on one hand, I can apply the MathStat models and a Bayesian approach. On the other hand, I apply a digital twin for more predictive maintenance. I can bring in much better decision and planning, at the same time give the levels of safety which we are looking for, and the profitability, the prognosis, the monitoring, everything what we are looking for. So while we do all this, of course, we need to understand that there is one more area in which people do need to work and where people do have a lot of difficulties is the change management in control rooms. Because we have moved from simple visual-based control rooms to menu-driven systems and computer-based automated control rooms. So the whole human engineering aspects of ergonomics, anthropometrics, intelligent alarms, online data processing, this throws in another plethora of research where the industry majors are really having a shortfall in that, and they are perpetually working towards better and better training, better and better upgradation. And this is an area which is changing too fast. So a technology forecast becomes a large requirement. But then we cannot possibly be working towards large-scale digital twins or large-scale availability factor improvement unless we have data at our fingertips. To have data at our fingertips, we need to have naturally more and more sophisticated control room data acquisition systems, which people can disseminate and understand, and many of it can work on AI-based. So this is an area, if properly integrated, we can not only have an intrinsic safety envelope, but the envelopes can go on to safety-related domains as well as to plant monitoring domains, diagnostics, and everything can get together. So effectively, you see, the safety system design is now intrinsically safe, as we said, and with smart sensing, actuation, the entire safety system design has given rise to intrinsically safe designs as well as designs which take care of availability and profitability of the plants. So the industry 4.0, what we referred, could be further enhanced if we are adding smart controls, sophisticated actuators, diagnostic systems, and smart materials all into it. Maybe we can talk of an industry 4.0 plus, as many researchers like you participate with industry and start working towards making industries a much more safe, much more acceptable place to stay. So tomorrow we can talk of an industry, of even a hazardous industry, even a so-called generation or any other high technology industry where public are skeptical about its proximity to cities. We can actually make them in actual proximity of city, thereby reduce the cost quite a lot. If we bring in all the points which we discussed on smart controls, prognosis, and the industry 4.0 framework, and bring it all together for everything. So this is perhaps the objective in which I'm trying to address the gathering. And as a person who have worked quite some time in industry and also had a blend of academic flavors on many occasions during my entire 3 decades of career, I feel we need to blend more young research minds, young minds who are coming out with very sophisticated startups and good startups which will feed to the industry, as well as their intellectual think tanks who can participate with industry, especially the critical infrastructure ones, and make these industries much more profitable, much more safe, or rather intrinsically safe for getting people and the public to have total confidence in them. And finally, as we said, these would be a game changer for bringing India into a much more industrialized place with better sources of employment, better sources of everything. And as we said, Industry 4.0 has actually thrown open new vistas where maybe I can control the industry from remote places without enough manpower, with AI being controlling the industries. So all that is possible, but then one needs to look into various aspects of hardware, software, controls, and also actuating devices, so on and so forth. So perhaps with this, I have spoken quite a lot. I'd be glad to take any questions. Only I would like to give one more acknowledgement that many of these images are available in public domain. They've been used purely for academic purposes. And some of these slides, of course, I had used for various other forums. So with this acknowledgement, maybe I'm glad to take questions if there are any. Thank you so much.
Thank you, sir, for your keynote speech. We will be waiting for some questions here. We are looking at some questions on the website. So my team is going to relay them to you. So Arnab, Vamika, are there any questions? Right. Okay. Thank you very much, sir, for your keynote address. It was a pleasure to have you on board here. As the inaugural keynote address, I think it pretty much hit upon the point what we were trying to make with RST 2021, where everything that is being covered in terms of big data, digital twins, control meters, and the future of research, as well as how academics and industry can collaborate together. The entire vision of RST was very well explained in this thing, and I am hopeful that this would be a good session which can be seen by every scholar, and some outcome or some insights can be looked at by them in the future as well. So thank you for that, sir. With this thing, we will be running a video for the upcoming sessions of RST tomorrow, and that would be the end of the inaugural session. So I hope to see you everyone in the tomorrow's meetings and tomorrow's lectures. All the details will be available in the upcoming video, and I hope you guys have a good time on the RST 2021 from April 2nd to April 4th, 2021. Thank you very much.
Thank you. Thank you so much.
Thank you, everyone. Thank you for joining us for the inauguration of RST 2021. We have a lot of merchandise on the website. You can go and check them out and buy as much as you can. And looking forward to meet you tomorrow. Thank you very much.